In this problem, it asks a simple question. What are the tensions in the cable? You are given a lot of geometric information. You're given the length of the rope, how much it hangs down from the ceiling, how heavy it is, or its mass, and then it asks you, well, what's the tension? And the tension in the cable, why is there any tension at all? Because there's a big mass hanging off the end of it. This cable, all tensions run parallel to cables. So this is going to have some tension, T. And because these are identical, they're identical in length, identical in angle, identical in each way, they're going to have identical tensions, basically by symmetry. You'd have to come up with a reason why they wouldn't have identical tensions. So there certainly is tensions pulling up on the wire. And if we were to figure out what that tension is, this is a force problem. And usually you have to understand what all the forces are to understand what any of them are, unless they're given to you. So if we just consider this object, this mass hanging here, and if we just look at the forces on it, maybe we can try to calculate what they are. Now, one special thing about this object is that it's stationary. It's not dropping, it's not swinging, it's not falling, it's not rising up. And that important fact tells us that if it's not accelerating, then F equals ma is always true, but if acceleration is 0, because it's not accelerating, then what that means is the net force is 0. And what is the net force on an object? It's simply the addition of all of the forces on that object. Just identify all the forces, add them up, and that's your net force. And since it's not moving, we know the net force must be 0. So the forces on here, well, we look for points of contact because forces are pushes and pulls. The points of contact are where the cables come in, so the tensions are on this object. And we should almost never neglect gravity. The force due to gravity is an object's weight, and it's because of the acceleration due to gravity, mg. Now that's going to be downwards. The tensions are pulling upwards. I'm going to, for people to see, I'm going to exaggerate everything. I'm going to make sure the weight vector is big. In your diagrams, you probably won't have to. I'm going to pretend that the tension vectors are big to balance out, just so it's clear drawing. So there's my tensions. All right. Now, it's so if these if these forces are going to balance, if my net force is 0, it also means that the net force in the x direction is 0, and the net force in the y direction is 0 independently. So I may not be able to figure out directly what tension is,